minute or two in case there are a few people still trying to log on. However, I'd like to welcome you all and thank you for your attendance. And we'll just give one more minute for folks. Okay, good morning, folks. We're going to begin. I want to officially welcome you all to the South Florida Water Management District's 2021 Water Conservation Expo. This event is normally held live in our headquarters in West Palm Beach. However, due to COVID, this year's event is being held through this Zoom webinar environment. My supervisor, Jim Harmon, is the section leader of the Water Supply Implementation Group at the South Florida Water Management District, and he will be assisting me today as we facilitate this event. He'll be handling the polling. There's a few polling questions that we're going to have come up on the screen, and we ask for your participation in that. And my name is Robert Wanvestrout. I'm the Senior Water Conservation Analyst for the South Florida Water Management District, and I will be moderating the event and bringing the speakers in. Jim, you want to bring us into our first polling question?
Sure. And just to let everybody know, there's also a Q&A button at the bottom of your screen. We will be taking questions, and I'll be facilitating that as well. And if you want to upvote some of those questions, you can do that. So this is our first poll. We're just trying to get a feel for who's in attendance and just asking what area you work in. Are you a property manager with utility, local regional government, or private consulting? Just give you a few minutes to vote on that. Okay, looks like everybody's fairly done, so we'll share those results. Looks like 72% is the largest amount for local regional government staff members, and you can see the rest of the results there. Okay.
Okay. Let's see. Let me just quickly, I want to give you I'm going to give you a little background on what the South Florida Water Management District is. South Florida Water Management District is one of 5 water management districts located throughout the state of Florida. They are broken up by watersheds, not by political boundaries, because we, as our name suggests, manage the water resources. All 5 water management districts have core missions of water supply, water quality, environmental water quality, that is, flood control, which is extremely relevant in our state, especially South Florida, and environmental restoration. So that's generally what we do with regard to water management. In Florida, we are an extremely water abundant state. We have almost 8,000 lakes, a little over 50,000 miles of rivers and streams, and we have more than 700 springs which is the largest concentration of springs in the world. And we get more rain than anywhere in the continental United States outside of Louisiana. And we have a whole lot of flooding in our history, as you are probably aware. And to me, if I was not inside of this and in the know, I would say, well, why should we worry about water conservation in a state that is so abundantly rich in water? And the answer is because Florida also has a history of droughts. And if you've lived here for any amount of time, even in the recent past, you probably know this. And this is because Florida has a very flat topography. We don't have a lot of natural catchment for water. A lot of it runs off the state. And we are not a tropical environment, as a lot of people like to say. We are actually a subtropical environment. And we can have either one of these two conditions, as you see on your screen, in a single year, or we could have a few wet years in a row and a few dry years in a row. Those conditions are normal for our subtropical environment, and this makes water management quite tricky. A lot of the rain that we do receive comes just during the summer months, and again, because of our topography, a lot of it just runs off. Then what we do capture on our land surface will go up to the atmosphere through evaporation and plant transpiration, because we do have a very, very high temperature for most of the year, and we are extremely green and lush in most of the state. So I want to make a point here with respect to why water management is so important in Florida. If we imagine these two bathtubs as our groundwater resources, you will see that and as the water management district, this is one of the things that we do. We monitor the water coming into our system and the water that's coming out of our system. And by that, I'm referring to every well that a city has to drill in order to provide drinking water to its service area, as well as farming and agriculture and so on, all the water that's coming out of the and there are quite a few straws that are all taking water from our groundwater resources. Currently, in the state of Florida, we're pretty much at a balance where the water coming into the system is roughly equivalent to what's leaving the system through our human use. Now, if we were to continue to just withdraw water without really monitoring it, we would see these effects happening that I've listed in these bullet points. We would see our environment beginning to suffer. Now, even if you're not someone who enjoys the natural environment, you have to recognize that it's not just the environment, it's also drinking water supplies that are affected. And you have to also keep in mind that a lot of folks who live here and a lot of tourists come here specifically because we have the environment that we do. And so sustaining damage to that environment can affect tourism and our economy in a lot of different ways. And as I said in the last slide, we are sort of at the balance point, but actually we're beyond the balance point in several areas, especially in South Florida. And we've already seen a lot of the conditions that I just mentioned, that I just showed you on this slide, already happening. We are seeing our environment beginning to suffer in different places. And it's not really going to get any better, because we anticipate, as long as it continues to snow in Buffalo and in New Jersey, folks are going to still want to keep moving to Florida. And each person that comes is going to bring with them their personal demands for water. And as we get more and more people, there begins to be more commercial development and so on. And our demands for water are projected to continue to increase into the future. So how do we meet those anticipated future demands? And there's really only one of two ways we can do that. I'm going to quickly go over these two ways. Specifically, let's look at the first one, which is increasing our water supply. And to do that, we can undertake these different engineering approaches, I'll call them. We can tap non-traditional water sources. And by that, I mean, normally what we do is we take water from our aquifer that has very, very high quality water. There's not a lot of saline in it. It comes up, it's very clean, and we can lightly process it and it's ready for use. But as we've tapped the limits of those traditional sources, we have to tap into deeper aquifers where the water is a little bit more brine. It requires a lot more a lot more energy and a lot more money to treat that kind of water and deliver it for folks to use. And then we can go down this line and you can see there's a lot of other engineering processes or approaches that we can take to continue to meet that demand. We could even desalinate the ocean water if we needed to. But there's a big however, and that is that all of these engineering solutions are extremely costly to develop, especially desalinating ocean water. Yes, we can do it, but it's very expensive. And these approaches have heavy carbon intensive effects or impacts that are associated with them. And let's keep in mind, we can do anything we want today, but it's really not going to be us that will be paying the price. And the price I'm talking about are impacts to the environment, the environmental quality, but also monetarily, because a lot of these engineering approaches require debt servicing that we put things in place now, but we pay for them over the next decade or two in order to have them successfully go forward. And I think this is a very, very relevant point. Let's talk about our second option. We can decrease the amount of water that we need. And we do that through conservation. And I'll just give you a little spoiler. Really what we're going to have to do, the end of this is the solutions that we come up with are going to consist of a blend of both of these approaches. But we want to mitigate how many or how much of the engineering approaches that we really need. And the way to do that is through water conservation. I'll quickly define that for you. What I mean by water conservation is using less water for a specific task, but increasing our water use efficiency and reducing wasteful use or loss. That's what we mean by water conservation. And it's always going to be the best economical alternative because it's usually easy to implement. It's quite less expensive than the engineering approaches I mentioned. The carbon footprint is a lot smaller. It reduces the stress on the natural systems. And ultimately, it can reduce, defer, or eliminate the need to develop those alternative engineering solutions that I discussed earlier. So whenever possible, we ought to keep water conservation as our water conservation ethic going forward in all the things we do. And I want to bring something a little bit, I want to drill, that's our big picture. I want to drill down to the perspective of a building owner or operator. And you see your water bill and you might think, well, water's really not that expensive. And that's true. However, there are a lot of other costs that are associated and affected by the amount of water that you use that will increase your operating expenses or decrease them based on the water efficiency at which your building is operating. And you can see I've listed a bunch of them. The easiest one to imagine is just heating your water. Your heating and electricity bills could go up if your efficiency is not good, is poor. And the same thing with, you can imagine cooling towers and things like that, chemical costs associated with those things and so on. So it depends on what types of activities are happening at your building. I mean, it could be very different between an office building or a hospital, for example. But in general, a facility's true cost for water can be almost double of whatever you see on your water bill each month. This is an extremely important point I'd like you to all keep in mind. This is how we need to think about water use efficiency at each of our facilities. Now, I'm hoping that I've captured your attention now with that remark about saving money, operating expenses at each of your facilities. So in summary, I want to say that water conservation, it's a theoretical thing on a regional scale if we don't have the on-the-ground implementation. And that's where all of you come into play. It's not just building owners and operators, it's agriculture folks, it's homeowners, it's everyone. It's commercial building, small building operators, all of that really have to develop and exercise a water conservation ethic. You folks are in a very specific and very impactful potentially role as you conserve water, because there's one of you for each building, or maybe two of you for each building, but the water use and efficiency that you preside over is much greater than just a single homeowner, if you will. So we have not only do we have a role to play, I see it as a responsibility for our future generations. And then again, of course, we can significantly reduce your operating costs. So this water conservation does not have to be something that's antithetical to what you're trying to achieve at your individual building for the sake of the larger community. It's something that will work for both the large community and your own operating expenses and so on. That's all I had planned to say. And Jim, I think you have another poll for us.
I do. Thank you for that recap. And I'm going to launch another poll. And this is not a test, but just more of a recap. Why should water use efficiency and conservation be goals of both the water management district and facility managers? Because water use in many parts of Florida is already at or beyond sustainable yield. Water conservation is less costly than large-scale engineering projects. Facility managers can play a positive role in conserving water. Water use efficiency can reduce facility operating expense, or all of the above. And we'll just let that go for just a few minutes. Not minutes, but seconds. And it looks like the votes coming in have slowed down, and the answer is obviously all of the above. So thank you for voting on that, and we can move on to the next speaker.
Thank you, Jim. I'm like to welcome Larry Clark. He will be our first speaker from outside the Water Management District. Larry is the Principal Sustainability Performance Solutions, the principal of Sustainable Performance Solutions, which is a South Florida-based engineering firm focusing on energy and sustainability consulting. He's a graduate engineer and a certified Green Globes professional, a LEED accredited professional, a certified energy auditor, and a Florida Water Star certifier, as well as a qualified commission process provider. He's also a frequent presenter and lecturer on a variety of green building topics, and he writes a semi-monthly article called Clark's Remarks, which is a column for the HPAC Engineering. And he's also on the advisory boards of several green engineering and civic groups, and I feel very privileged to have Larry as one of our speakers. I'd like to turn it over to Larry. Larry?
Thank you, Robert. And if you could bring up the first slide, please. So the South Florida Water Management District has been hosting these water conservation expos since 2009, with the exception of last year when, due to the pandemic, it wasn't held. All of the previous expos have been live in-person events held at the district headquarters, as Robert mentioned. In addition to the informative presentations and the chance to network with other water conservation professionals at these expos, there were vendor fairs that gave expo attendees the opportunity to see and learn about the latest in water conservation technologies, equipment, and strategies. So again, as Robert mentioned, this is the first, and I certainly hope it's the last, virtual expo. And unfortunately, today we're not going to be able to put our hands on any hardware. Hopefully, however, we will walk away with some tips and tools to help us understand the need for water conservation in commercial buildings, as well as some of the means of reducing water use in those buildings. This is actually the third expo that is focused specifically on water conservation in commercial and institutional facilities. The first two were held in 2010 and 2013. Expos in other years have addressed such topics as public water supplies, agriculture, nursery and landscape irrigation, and water conservation outreach and education. Next slide, please. There it is. Okay. So some of the initiatives offered as part of the district's comprehensive water conservation program include promoting appropriate landscaping through the University of Florida's Florida-Friendly Landscaping Program, financially supporting local water conservation projects with a cooperative funding program, supporting the Florida Water Star program, which is a water conservation certification program for both residential developments and for new and existing commercial properties, and supporting accreditation of landscape and irrigational professionals interested in water efficient design and installation of those landscaping and irrigation systems through the AP accredited professional program. The Water Star certification and the AP program are addressed in detail on the Florida Water Star website, which is shown there, floridawaterstar.com. And information about those other district programs is available at the district website, also shown there. Next slide, please. So why is water conservation in commercial and institutional buildings so important? Well, we can look at some pertinent data and statistics. A study released in 2017 by the U.S. Energy Information Administration indicated that 46,000 of the largest, which they define as a building more than 200,000 square feet, 46,000 of the largest commercial buildings in the U.S. use 2.3% of our country's total public water supply, 2.3%. That may not at first blush sound like a lot, but in 2012, that represented nearly 8 billion with a B gallons of water per day. According to the study, hospitals, correctional facilities, and hotels in that order were the largest water consumers. And as you can see in the graph, they also had the highest water intensity in gallons per square foot. Next slide, please. Of course, those types of facilities, hospitals, prisons, and hotels, represent a much smaller share of the total building inventory than do, say, commercial office buildings. A typical office building, for example, can have a water intensity which is less than a third of that of a hospital. But here in the United States, there are something like 97 billion square feet of office buildings compared to only 2.3 billion square feet of hospitals. According to the EPA, those hospitals, office buildings, and other commercial and institutional facilities together use 17% of all publicly supplied water in the US. Next slide, please. Interestingly, regardless of a building's in use, some 30 to 40% of its water consumption, and you can see it's just a bit higher for schools, but 30 to 40% of the water use in commercial buildings is typically for restrooms. So those are obviously low-hanging fruit when looking for ways to conserve water. A number of state and national programs support water-efficient plumbing fixtures and equipment, including the Florida Water Star and the EPA WaterSense programs. And the efficiency of these fixtures is constantly improving. Some of you may remember that in 1994, we began replacing 3 to 5 gallons per flush toilets with 1.6 GPF, which, by the way, became mandatory for commercial buildings in 1997. By 2014, 1.28 GPF was the new standard in many jurisdictions. 1.1, 1.6 GPF dual flush toilets were gaining in popularity. And today you can buy 0.5, 0.8 GPF dual flush toilets on the internet. Lavatory faucets and shower heads are also much more efficient than in the past. And even simple, inexpensive aerators provide tangible water savings. I like case studies, and here's a first-hand one on faucet aerators. Several years ago, our firm did an energy audit for a 5-story, 184,000 square foot office building in Miami. One of the recommendations as a result of that project was to install aerators on the faucets in the employee break rooms. That was the simplest and less costly of all the recommendations as a result of that audit. They bought a package of 10 aerators for $6.90. That's 69 cents a piece. And they installed them in the 4 employee break rooms. Believe it or not, the aerators reduced the water consumption by 77%, saving 99,000 gallons of water per year at a cost savings of just under $500. And note that the cost of the water at the time was $3.72 per CCF. The aerators were installed first thing in the morning and had literally paid for themselves before we went home that night. You can't get much more bang for the buck. And in the next phase of the project, after implementation of the other energy and water conservation recommendations, they successfully achieved Green Globe certification. Next slide, please. If we drill down on the water consumption in office buildings by their end uses, we see that nearly a quarter of that water goes to landscaping irrigation, which is the largest use after restrooms and HVAC. That's, of course, another major focus area of the district, primarily through its year-round landscape watering restrictions, which, by the way, apply to both residential and commercial properties. Adopting water-smart landscaping and irrigation practices, such as those required by the Florida Water Star program, is especially important here in South Florida, where we get nearly 250 days a year of sunshine. Our third speaker will be addressing that in more detail. Clearly, conserving water in any commercial or institutional building should start with the development of a water management plan and should include an assessment of the building's water use in order to identify opportunities for reducing water consumption. It should also provide a means for tracking the results of any water conservation measures that are implemented. The old saying that you can't manage what you can't measure certainly applies to water conservation, and both the next speaker and our final speaker will be addressing that. Of course, many of the water conservation measures in commercial and institutional facilities are just common sense maintenance practices, like regularly checking for leaks and promptly repairing them. Not as obvious, perhaps, are measures such as retrofitting older, less efficient water-consuming HVAC systems and equipment. Next slide, please. As a vacation destination, South Florida has a plethora of hospitality properties, and all of our visitors want clean sheets and towels. So it's not surprising that hotels use 16% of their total water consumption in their laundry operations. That's almost twice as much as the 9% of total water used by hospitals for their laundry operations. Of course, a large part of the difference is due to the fact that hospitals use 15% of their water for medical equipment. And much of that is for once-through cooling, which, as water conservation professionals, we know is the bane of water conservation. A full-service hotel, that's a hotel with a restaurant, pool, and banquet facilities, will typically wash 12 to 14 pounds of laundry per room per day, and that's both linen and terry. In a resort, where you add golf or tennis facilities, that can jump to 16 pounds per room per day. Since those on-site laundry operations are not only water intensive, but they're also energy and labor intensive, many hotels have elected to outsource their laundry services and have contracted with off-site laundries that provide pickup and delivery. Another option that I got to see firsthand is robotic laundry equipment on the hotel's property that is actually staffed by contract personnel, not hotel employees. The hotel management told us that option resulted in water, energy, and labor cost savings. Because hotels have unique operations, the EPA created the Water Sense Hotel Challenge, a program designed specifically to help hotels save water and energy and reduce their operating costs. And the Southwest Florida Water Management District, you recall that was with one of the other districts that Robert showed us the slide for. They developed their water conservation hotel and motel program known as Water Champ as a free towel and linen reuse program that encouraged guests to use their towels and linens more than once during the stay. Some of you may have stayed in hotels where they had the card that said, if you want to use your towel over, hang it up. If you want to change, throw it on the floor. According to program administrators, Water Champ saved an average of 17 gallons of water per day per occupied room, while also saving electric energy and reducing detergent use. Next slide, please. So many of us participating in this expo today have to sell our products or services to commercial building owners and managers. And for a lot of those owners, it's not about saving water as much as it is about saving dollars. So for those folks, return on investment is everything. Again, citing data from the Energy Information Administration, we see that approximately half of our existing building inventory in this country is now more than 40 years old. Many of those buildings have not been retrofitted with more efficient fixtures and appliances, so there's a huge potential for very significant cost savings in those properties. Next slide, please. So let's do a simple ROI model for a very small office building. We'll assume that this is an older building that still has single flush 3 GPF toilets, that there are no urinals for the men, that there are 15 full-time equivalent employees, that there are no or few visitors who would very rarely use those restrooms, and that each employee, male and female, flushes 3 times per day. That's a typical value used in several of the green building programs. Since OSHA only requires 1 toilet for up to 15 employees, we'll assume that there are 2 bathrooms, men's and women's. Remember, I said this was an older building, and each is equipped with a single 3 GPF toilet. Flushing 3 times per day per employee for the typical 260 working days per year gives us a total of 35,100 gallons of water consumed per year. If we assume a water and sewer cost of $15.88 per 1,000 gallons, that's an annual cost for just flushing those toilets of $557. If we change out those 3 GPF toilets for 1.28 GPF toilets at a cost of $245, our investment for the 2 toilets is $490. Our savings is 20,124 gallons of $320 a year. That's an ROI, by the way, over 20 years of 1,304% and a simple payback of about a year and a half. Now let's do the same calculations for 1.1, 1.6 GPF dual flush toilet. We assume a 2-to-1 ratio for a half flush versus full flush and a cost per toilet of $159. By the way, I got all of those costs from prevailing prices at a very well-known big box store. You probably have one in your neighborhood. Anyway, now our simple payback period is about a year, and the 20-year ROI is 2,025%. Those are the kinds of numbers that owners and chief financial officers want to see. Next slide, please. For commercial and institutional facilities seeking green building certifications, water conservation is a must. LEED, Green Globes, Florida Green Building Coalition, and many others all require buildings to demonstrate significant reductions in water, either through compliance with prescriptive requirements or by demonstrating successful performance outcomes, or in some cases both. For example, the just released Green Globes for Existing Buildings 2021 allocates 18.5% of its total points, that's 185 out of a possible 1,000 points, to water. Of those 185 points, 65 are performance-based and 120 of them are prescriptive. There are 3 paths available for achieving the performance criteria. 2 of them are applicable to commercial buildings. The third's only for property types that are at least 75% multifamily and receive an EPA water score. The prescriptive points include water sense labeling as a significant factor and have varying requirements based on the type of the building. Is it an office? Is it healthcare, hotel, casino, restaurant, etc.? Florida Green Building Coalition commercial certification criteria includes prerequisites, one of which requires a minimum reduction in water use. Until you've reduced your water use in that building, you can't even apply for the certification. FGBC also recognizes the Florida Water Star certification as satisfying some of its requirements. Next slide, please. So hopefully we all understand the why of water conservation in commercial and institutional facilities. Now our expert speakers are going to help us with the how. If anyone has any questions before we move on, as they told you earlier, you can use the Q&A button. And please, if you think of something later, my email address is up there. Email me your questions. I'll do my best to get an answer. Thanks. Rob, it's yours.
Hey, Larry, this is Jim. I would just say we don't have any questions for you yet. And I would just remind everybody there is a question and answer button there at the bottom, which will open a separate screen. If you type questions in, we'll be able to get to those. I don't see any questions for you at this time. So we're actually going to run a second poll. and I'm going to launch that now. Which areas of water use account for approximately 30 to 40% of all water use across all building types discussed? Is that for cooling and heating? Is it for restrooms? Is it for landscaping or for kitchens? Just give you a few more seconds there to vote. Okay, looks like everybody's slowing down on the voting, so we're gonna end that poll. Looks like most folks selected domestic restrooms, which is the correct answer. So thank you for doing that. Turn it over to you, Robert.
Thank you, Jim. At this time, I would like to welcome Dave Unger as our next speaker. David Unger is the founder and CEO of Sentient Buildings, a building automation company that helps property owners and managers conserve energy and reduce operating costs through the use of cloud-based wireless Internet of Things networks. David is a pioneer in the use of the internet and web-based platforms for this purpose. Prior to finding Sentient Buildings, David served as the Chief Operating Officer of U.S. Energy Group and has helped launch several other product innovations for remote building monitoring and control through cloud-based platforms. He's a frequent speaker on the topic of building automation for energy efficiency. We're extremely delighted to have him speak. And with that, I'd like to turn it over to you, David.
Thank you, Robert. Good morning, everyone. So what I'm going to cover today, first, what I wanted to do is just kind of give some background information about how we gather, collect, and integrate data sources from remote sites so that we can evaluate it for analysis in a reliable, consistent fashion. And then I'm going to get into specific applications for the technology and water use management, and how we remotely monitor and provide analysis against that data. So Robert, if you want to go to the, yeah, okay. So, as our name implies, sentient is to bring power of perception or bring some conscious awareness to buildings. And really that's done through instrumentation of wireless devices that can evaluate and interrogate, sources of energy use or water use, and also provide some control feedback to regulate that use in some way, whether on the HVAC side or in cases, where water waste is happening, we're moving in the direction to provide some preventative ways to reduce usage. So, our goal here is to provide, the best possible outcome for building owners and their tenants to, use water and energy only when it's necessary and and really focus on elimination of waste. So next slide, Robert. Okay, so I'm going to talk about how we do the remote monitoring and management. I'm going to get into wireless sensor networks that we use. Then I'm going to specifically focus on, most of my time is going to be focused on toilet and riser leak detection. I'm going to touch on some water damage and flood prevention through a case study that we have. But really, based on, what Larry went over, we all see that most of the water waste is coming, or not necessarily waste, but usage is, around restrooms and our use of toilets and showers and bathtubs. So I'm going to cover that and really focus in on that. So Robert, next slide. Okay, so the water management services that we focus on is we integrate sensor networks and pulse meters. We focus on driving open protocols. So our big goal here is to integrate with a variety of different hardware and solutions that are focused on monitoring, measuring, or controlling water use. We look to monitor that use in real time so that, immediate action whenever it necessary can be taken. In some cases, immediate action means looking at something over a duration so that you could determine that a leak or an event has happened. And I'll get into that a little bit. I threw, I don't think this is, or maybe programs in Florida as well, but I know we're largely focused in the Northeast and the New York area market. But we do have projects across the country. But in New York City, there's the Enterprise Green Communities Act. It's now a requirement that there's sub-metering of water usage, not for billing purposes, but for determining and detecting waste. I'll cover that some more. And that's in all new construction projects that are going up for affordable housing. So Robert, you want to move to the next slide? So just in terms of the technologies that we use on the far right, IoT really represents wireless sensor technology, wireless sensor monitoring and control technology. But our focus is to provide an integrated system so that we can bring all the data sources together in a building to provide a holistic view of building operations for the operator. So where data largely went unseen, our goal is to expose that data so that it can be used in building operations. And on the right side here, I just wanted to kind of, go over how these networks are deployed and how we collect data. We have very long range wireless network sensors that we can deploy with low infrastructure costs so on the left of my integration diagram, you'll see the wireless device networks. Typically those are water meters or micrometers or some type of water use detection. That flows up to a gateway device that is resident in a building, also connects with other systems in the building so we can monitor other HVAC systems, cooling towers, condenser pumps, and the like. We can bring all of that together into a central gateway, push that to a cloud server for analytical use so that we could determine what is actually happening in a building over time. Okay, next slide. The wireless technologies we use include, water leak detection, metering, other wireless sensor networks. We also connect to building management systems. We do a lot of work in instrumenting PTACs and fan coils, and we do a lot of condensate actual leak detection for damage prevention. So I just wanted to give you kind of the full scope of all the areas that we're focused in. And how we could bring that together to look at all the individual sources that may impact water usage to evaluate, how much is being used, what can be done to prevent future waste. I'm going to kind of do a deeper dive now into some of the technologies specifically around toilet usage. So Robert, if you want to go to the next slide, please. We offer a solution for point of use leak detection, and this is used through the use of, on the far left there is a micrometer that we use that can measure down to a tenth of a gallon of usage, how much is flowing through the meter. And that's connected to a wireless transmitter and a data collection device that can interrogate the data at the source of use and then transmit that data to a gateway, as I described in the prior slide, which then goes out over an internet connection to the cloud for analysis. Robert, next slide, please. So, typically, we're looking at, this is just a typical riser diagram in a multifamily building. So what I want to identify, we are looking at two ways of looking at water waste. One way is through point of use directly. So whether that's the toilet, a dishwasher, a sink, a tub, we can install these micrometers at the point of use for measurement of ongoing usage to evaluate whether or not the proper amount of water is being used on a daily basis. We can do that at point of use, but we can also do that on water risers. With water risers, obviously it's going to be a little tricky trickier to identify where the source of the leak is once it's identified, but at least it can isolate areas where water waste is occurring within a building, so that building operators can, identify and at least start from a point where they can identify where the source of the leak may be happening or occurring from. It's obviously a more inexpensive way to get these solutions into buildings. However, it doesn't give you the granularity of point of use metering. Robert, if you can move to the next slide. So just to dive into specifically, because, as Larry touched on in the last slide, I mean, a lot of water use, majority of the water use and water waste occurs at the toilet. I know that we see a majority of problems arising not only by the amount of water with each flush, which can be reduced with some of the newer toilet models and technologies for flushing, but also what happens when there's a problem, right? And in this case, in the older style toilets, you'll see that there are several areas where problems can occur, right? We can have an open flapper that's not seated properly or cracked and causing slow leaks. We can have an improper float adjustment on the arm of the toilet, so that that adjustment may cause the toilet to constantly leak and continuously running into an overfill of the toilet. The valve can also get stuck open. With the flush valve can get stuck open with the chain pull, which happens all the time. And these are all silent culprits of water waste that go completely unnoticed. So even if you do have a newer style toilet, you could still run into these problems where you could have cracks at the or condition where you have a vacuum breaker that's leaking and causing the valve to remain open, for example. So there are still issues with the newer style toilets that, and these types of leaks go completely unseen, right? Unless you're looking at overall water use, you can start to see that you have problems, but you don't know where those problems are occurring from a single meter. It really requires some granularity and monitoring of what's going on to get to the source of the issue. So Robert, if you want to move to the next slide. So, just going over how we identify these toilet leaks in our analytics and what we're evaluating. We assume, and this isn't a multifamily environment, but this could also be applied to any commercial environment, to hospitality, to other areas in terms of, what is the occupancy assumptions that you're going on? How many office workers or how many tenants do you have in an apartment, or how many hotel guests are staying in a room per week? And you could really come up with what is normal operation, like how much water use should we be seeing with toilets. If they're in older toilets, it's 3 to 7 gallons per day. If they're newer toilets, 1.6 to 1.2 gallons per flush. I'm sorry, I meant to say not per day. But what we're trying to identify is, okay, we have normal operation as our baseline. When does a leak occur, right? And we have different scenarios where we can identify when we think that there's a flapper valve leak, a potential overfill leak, or a potential valve leak based on the rules that I've broken down below here. In terms of, what kind of daily usage are we seeing at that toilet, where we would consider 40 gallons per day on each toilet, normal usage, with the assumption that you have 2 to 4 tenants in an apartment. Once you start creeping up where you have more than 100 gallons of daily water usage, you have some kind of leak with the toilet. That should be an abnormality, and all of these values are adjustable so that we can fine tune how we're identifying these leaks on a per use case basis. Then we could look at the potential overflow, which could cause up to 850 gallons of water waste per day, and then a full on having a flapper leak, which can go up to 1,000 gallons of water usage a day. And then if you have a fully open flapper with an open leak, I mean, we've seen instances of more than 1,000 gallons of water waste per day. And as you can see, I mean, these are, you know, we start with smaller numbers, but these numbers gradually increase. And the number, based on the number of toilets that might exist in a building, this amount of water waste can become a very significant problem for building owners. Robert, if you could go to the next slide. So, I mean, this is just some kind of screenshots of how we notify on specific issues, right? You know, this also comes via email, text message. We provide visibility via mobile device so that you can see, the building operators can see these issues as they're happening, or, you know, when we trigger the alarm to occur. So some of these are happening on a 24-hour basis, but some are, you know, detecting usage spikes that are outside the average normal usage patterns that we see in a building. So, you know, this is just an example of some of the conditions that we've identified for point of use leak detection. Robert, if you want to go to the next slide. So I just want to touch on riser leak detection. I mean, this is an option that, you know, at least here in our market, in our area that we do a lot of work, you know, most building owners are opting to use riser leak detection. I'm showing an example here where you see the timeline above. This is where we've identified a riser leak issue where it's just putting a single meter on a riser and we're recording data and transmitting it to our cloud platform. But you can see from the hours of midnight to 5 a.m., we've identified a scenario where we have constant use in an apartment where, you know, below there you see the data mapped where we're seeing at least 10 gallons of water use through per hour through the course of between, you know, the hours of 1 a.m. and 4 a.m. That is where, you know, we identify a source of a potential leak, right, on that particular riser, because you have constant use overnight where you don't have a lot of activity. This is for multifamily, but this would also apply to office buildings where you don't have anybody typically in the building over the nighttime hours. So if you move to the next slide, Robert. So, you know, we look at, you know, riser leaks a little differently than we do point of use leaks, but we're looking for, you know, continuous flow in a riser during periods of low usage, right, which are typically late night periods. We then do some machine learning based on historical data that will tell us what unusual data or water use is on a riser, so that we can determine that we have either an unusual spike in usage based on that historical data. We also use the average occupancy of the space as a metric in determining if we're exceeding patterns of abnormal usage. Just a quick comment on that. New York City, you're able to, from this particular value, determine if you have over occupancy in some apartments. I mean, this is some way of also determining if you are having, you know, you have more occupants in a space than you really should. And then, you know, we obviously look at abnormal usage patterns that, you know, if things get just irregular in usage, we're able to call those out and identify and alert an operator. So Robert, next slide, please. Okay, just a quick case study here. This is, I mean, we also do leak detection for flood prevention, you know, where we have leak detection in condensate trays. But in this particular case, we identified a massive water leak at a very tall building here, 90-story high-rise here in New York City. And we were able to prevent, you know, $1 million of water damage in the building and you know, thousands of gallons of water waste. It was done through just a wireless IoT device network where we were able to put flood probes in areas where, you know, we could detect mechanical system leaks. In this case, they had a domestic house tank overflow because the pump failed. I'm sorry, the float on the tank failed, and they overflowed the tank. And the tanks were interior to the building and caused a major water leak and some major flood damage. And so we were able to prevent that from happening on the first time we prevented that. We saw a payback in less than a month. And in most cases, all of the technology that I described on an ROI basis for toilet monitoring and for riser leak detection are also, based on the number of leaks that you're detecting, I mean, pay for themselves in very short order. In most cases, I mean, it's really sometimes hard to project if you're not identifying any leaks, your paybacks are going to be lower. But as soon as you identify that first leak, the prevented waste of what that leak would cause over a long period of time would result in paybacks, in many cases in under a year for the solutions that we're installing. So Robert, if you want to, I think that's all I have today, but thank you everyone. And Robert, I really appreciate the opportunity to present as a panel today. So thank you very much.
We're privileged to have you.
Thanks, David. I don't see any open questions for you at this time, and just want to remind folks that the Q&A box is there. If you want to ask a question for David or any of the speakers, we can also come back to them at the end if we have time. So back to you, Robert.
Jim, I think do we have a polling question at this time?
We do not.
Okay. We're going to skip ahead then. I want to introduce at this time Kevin Hunt. Kevin Hunt is the CEO of Naka's Landscaping. He's been with them since 1999, was recently appointed the CEO in July of 2020. He served as the general manager, sales manager, and arbor care manager, and irrigation division manager in more than 20 years tenure. He's also a LEAF certified landscape inspector and an ISA certified arborist with the tree risk assessment qualification. I think he's more than qualified to discuss water use efficiency in the landscaping and irrigation of commercial and institutional buildings. So with that, Kevin, welcome to our presentation, and take it away.
Thank you, Robert, and thanks everybody for having me. That was quite the setup there. You make me sound like I know things, but I do know a thing or two, I guess. And being in the business for some time, we've seen a lot of things happen, and we've definitely seen the evolution of water use and how important water use is as a cost. For us as a commercial landscaping company, one of our biggest concerns is managing costs for our clients. And if you would go to the next slide, we can start talking about what I typically deal with, which is landscape irrigation and watering. Currently, and I don't know that everybody's aware of this because I keep hearing it out in the world, but South Florida is still under water restrictions. And as we are under, so we're on a call here with South Florida Water Management District, they will tell you we are still under water restrictions. This has not changed. So as such, we all need to be conscious of this. The Miami-Dade County, currently now is only having, I believe, watering 2 days a week, no watering from 7 a.m. to 7 p.m. Broward County is also under a 2-day-a-week limit, and it looks like that's no watering from 10 a.m. to 4 p.m. By the way, I took this information from South Florida Water Management District's site. Robert or any of the other folks, if I am speaking out of school here, you guys jump in and let me know. There's some nuances per county. You can have more restrictive restrictions in your municipality or your county than South Florida Water Management District allows for, but you obviously can't have a less restrictive restriction. And I'll stop using the word restriction now. Can we have the next slide, please? So we start to get a little bit of a difference when we move up the coast a bit. Palm Beach County is under a 3-day-a-week water restriction, no watering from 10 a.m. to 4 p.m. However, Boca Raton specifically, no watering from 8 a.m. to 5 p.m. And there is a lot of density in Boca, and I think maybe its proximity to Broward County is speaking to that. So next slide, please. With that being said, counties want you to save money and water. So I'll pause for a moment if we wanted to answer Patrick's question. According to the website, the Dade County website, that is what they indicated, that water restrictions were from 7 a.m. to 7 p.m. So that's, again, I wanted to talk about what counties are offering. And here you can find out more here on this link to the Miami-Dade website. They have a tremendously robust page that talks about water conservation, and there's rebates available for all kinds of things from toilet modifications to irrigation modifications. Miami-Dade is very aggressive on this front, and I really suggest that anybody in the county go and check out that site, not only for your commercial property or your residential property, but maybe even your single family home. Everybody has access to this. It's like I said, it's very powerful. Broward County has a whole month-long series on water conservation, and you can check out more there on their water resources page and their Water Matters days. The entire month of March is dedicated to water consciousness. And of course, Palm Beach County, the Soil and Water Conservation District, has a lot of information to offer up on that front as well. You go to the next slide. So irrigating in the landscape, you're either pulling water out of a lake or a pond or a well, or you're using municipal water. And anytime you're using municipal water, that costs money. That costs the owner money, and as a property manager of whatever it is you're managing, this is a real impact. When a city water system, generally speaking, is built, they more often than not, because somebody is trying to save a buck, they do not install what's called a master valve. And so you've got a main line that's directly connected to the water meter that is feeding your zone valves, so that every time you turn on the controller, your zone valves open and water comes out, which is great, except when a valve fails or you get a main line break. If a valve fails and stays open, because that water line is under pressure, it will constantly run. And I've seen it dozens of times over the years and it always happens at a retail center on at 9 o'clock at night, and nobody catches it till Monday morning, where the water now has run for 48 to 64 hours. And that is just lighting money on fire. So one of the things that's a really simple solution for any city water system would be to install a master valve. All new controllers, as long as you're not using something from 1982, have a way to allow it to be controlled via a master valve. Master valves are installed after the water meter, but before your zone valves. And as you can see in the image here, where that's located, this happens to be a Hunter controller diagram, but similar, you get the idea. It's a master valve prevents water from just willy-nilly running. It only opens up when the controller opens up and allows water to then be active in the main line. So it definitely prevents water from just running willy-nilly. Next slide, please. The downside, though, is that there are some things that could happen. If a master valve, like other valves, could get a clog or a break, or the solenoid could fail, and then it's open, and then other things could happen. That might go undetected until there is an issue. There are potentially issues with water hammer coming through the pipe, as that valve is, now that water line isn't completely charged all the time. Every time that valve opens, water comes charging through, hits elbows and joints, and can potentially push things apart over time. It could also be argued, though, that anytime you're running any system, that potentially could happen. So I think that from a dollars perspective, it's pretty apparent to me that the pros outweigh the cons on this. A lot of things would have to go wrong for having this system fail for it to really impact you. However, if you don't have it, and this is not a costly expense to modify, it's probably, depending on where your clock is and where your meter is and where your valves start, it's probably under $1,000 modification, maybe even less. So this is a very simple way to capture or catch a potential big, costly problem before it ever becomes a problem. And if you wouldn't mind switching to the next slide, please. The other thing that we're starting to really see is virtually every major irrigation manufacturer is coming out with systems that are satellite connected, cell connected, smart systems connected to satellites. We're using a product now, and I'm not pitching them because they're not paying me, but just we're using a product now called Weathermatic that has dramatically impacted property water use. We've done some beta testing at a few places for some property management companies, as well as for Citrix Systems. At the Citrix Systems campus, we, in the month of, I think, September of October last year, it was a particularly rainy month, and we had set the system to run a limited number of minutes based on what was projected based on water restrictions, what should have been allowable for that property. I think it was something like 1,700 minutes. In that month, because of the satellite connection and because of the internet connection and the whole kit and caboodle, the system ran for 32 minutes on a city water system. That is an uncanny reduction in use. And it absolutely saved them thousands of dollars in that month. So this is real money. We've had other sites where they've had city water systems where we've made conversions to wells or pumps. On those sites, I know they were spending $5,000 to $6,000 a month on irrigation water. What is $5,000 to $6,000 a month back in your organization's pocket? I mean, that's an absolutely game-changing amount of money. In fact, so much so, in fact, that on a lot of commercial landscape sites, it's so much money that it could essentially subsidize your landscape maintenance service. So this is a very, very real opportunity to save substantial amounts of money when you've got a city water system. The money is, I'm saying, it's that much. The other side of the coin, that's with city water systems, and you're saying, well, I'm pulling out of the pump or the well, I don't care, well, okay, but that's still water that is part of our aquifers, and we need to be conscious of from a grand water use perspective. If you're using some of these smarter systems, it allows you to use technology to remotely operate the system. And on bigger sites that maybe require 2 irrigation technicians to try and run, where you've got one person at the controller switching zones and one person out in the field identifying problems, and that's not an atypical thing at all, you could have one individual remotely operating the controller from their smartphone or tablet, which immediately eliminates the need for a second person. And now that person can maybe even do this a little more efficiently and faster. We've projected that could be as much as 20 to 30% in just a labor cost to do that service as part of a landscape maintenance program. Again, that's savings to the client, which in this case may be you guys. You should talk to your landscape provider or your irrigation system provider or maintenance provider to ask them about these things to help lower your operating costs, both with the water itself and from a labor perspective. And next slide, please. So another thing that I think is very, very important, apart from actually all the water, is what are we planting in our landscape? I know they look pretty, but I'm absolutely an advocate for not using annuals and perennials. And please don't tell my flower provider that I ever said this, because flowers require frequent watering. When they're in beds that have things that don't need that much water, you can impact the other plants. We tend to see a lot of things planted with hardy material that doesn't need a lot of water. You see a lot of green island ficus being planted these days. Arbicola or dwarf schefflera. These things are extraordinarily croton. These things are very, very hardy. Don't need a ton of water once they're established, but we'll put a flower bed right alongside of them and water the hell out of that for, every day for 5 days. And it can impact your other plant material greatly. So there's a lot of natural color to be had within South Florida's plant palette. And with some clever relocating of things, or maybe identifying of spaces that you want to have some color, it's my opinion that we should be smarter about what we're using from a lot. And while some of that may not be long-term use, a flower is only going to get you about 3 to 4 months of it looking decent. Wouldn't you rather spend that money on something that's going to give you a year, 2 years, 3 years? I think there's some economics there that definitely warrant it. Second thing that I would love to see people do is stop using turf grass. And again, am I slitting my own throat as a landscape maintenance company? Maybe, maybe not. I don't think people will stop using grass. But in any kind of small footprint setting, if you could stop using turf grass, it would save you a fortune in water, a fortune in maintenance, and a fortune in chemicals and fertilizers. Turf grass is the most maintenance heavy part of any landscape. It's 2.5 times as much labor to service as plants and ground covers. It requires the most fertilizer, and that's a massive contributor to algae blooms, which is another big issue, which is part of why we have a watershed act and why we talk about things like Florida friendly landscapes. I think that if you have the way to get turf grass out of your landscape, you will save significant money, both from a maintenance standpoint and from, well, basically from a maintenance standpoint, but also the bigger sort of wider impacts of what it is to have turf grass. The county, or rather not the county, Fort Lauderdale is currently weighing the merits of a blower ban because of some people, some providers blowing landscape debris, or usually turf grass, like cut turf grass, into storm sewers. It's certainly a problem. I don't think the blowers are the problem. I think it's just not training. But the problem wouldn't exist, especially in some smaller footprint properties where if there was no grass, you can trim a bush, and I think if you let the leaves just decay underneath it, it's the best thing you can for it. To let those leaves decay and become part of your soil underneath that bush. You don't want to let it get too crazy and have giant leaf litter under your bushes, but that's another story entirely. So I think, is that my last slide, guys? Yes. So I didn't know if anybody had any questions or comments or thoughts, but this is my radical approach to what I think we ought to be doing and what I think the future looks like. So I appreciate everyone's time, and I hope I provided some quality information.
Thank you, Kevin. I don't see any open questions for you at this time. We will do another poll though, and I've launched that now. So what should you consider alternatives to having annual plants in your irrigated landscape? Annuals that require frequent watering, Florida native plants, annual plants that require frequent replacing, or all of the above? Okay. We're going to end that poll, and it looks like everyone said all of the above. So back to you, Robert.
Okay, thank you. Let's see, next slide up. Jim, I think you have a polling question for us?
We just did it.
Sorry. Okay, let me introduce our next speaker, who is our final speaker. His name is John K. Scott, and he's the Managing Director, Real Estate Management Services for Florida. He's a member of the Colliers International Executive Leadership Team in Florida, where he directs a portfolio of over 285 retail, office, and industrial properties, totaling more than 32 million square feet, and leads a team of over 110 professional and support personnel specializing in real estate management services. With that, I'm going to ask John to step in, and he's going to provide a case study, the Park Tower building. John?
Yeah, thank you very much. I appreciate that, Robert. And thank you to South Florida Water Management for inviting me and for a wonderful panelist and for BOMA, Miami-Dade. So a couple of things, just more on my background. I'm the global head of sustainability practice group for Colliers International. I work directly as the commercial real estate expert on the Miami-Dade Green Print program we went through in 2009, 10, and 11. That's still in focus, where we looked at all factors for Miami-Dade County to reduce emissions, water consumption, and worked with the Miami-Dade Water and Sewer. I helped credential the Shanghai Tower, the second tallest office building in China, on several trips over to Shanghai. And one of the major areas that we worked on was the water retention through cisterns and building flows off the building when they have rain and hurricanes, very similar to Miami, so that they would save that water. And then I was the first chair of the Better Building Alliance, a public-private partnership with the Department of Energy, where I worked directly with the national labs on sub-metering, which is what this group is about, and how we can implement more sub-metering, because you cannot measure, if you cannot measure something, you can't change it. So benchmarking is key to all of this. So I appreciate that. And a quick shout out to a couple of my friends on the call, which is Ed Mazzei, Drew Smith, and Monica Bardino, who are good friends. So we get started on this. I had many buildings in Florida to pick from. In Miami-Dade, I took the Southeast Financial Center to a LEED Gold, and we did some significant work. I consider this the most comprehensive building that we've completed to date out of many. And so I felt from the water perspective and from the sub-metering perspective that this would be the best. So let me bring you into my world a little bit. I work with funds that some have green funds, sustainable funds, but the majority are just investors into commercial real estate. And to present a plan, which all of our wonderful speakers have went over, you have to give a strategy, and the strategy has to end where there is a positive improvement to either the EBITDA of the building, whereas your operating expenses minus your income, and or that at sale and acquisition, there is a big component of it that you're going to make money off of the project. So what I do is put a strategic group together and try to work towards doing that type of work. So let's go to the first slide and I'll present the building. There we go. So Park Tower, 552,000 square feet, built in 1973. For those who were not around back then, that's when the oil embargo hit and gasoline and oil prices skyrocketed. So this was built before energy conservation was even a concern in this country, and was built to different standards. So that's a key component in what we're going to discuss. At the end of it, you can see some of the highlights that we have down at the bottom, but I'm going to focus on the 22% water reduction level. And one of the key components in commercial office buildings in particular, or any retail or medical or anything else, is the occupancy of that structure. So when we start with this component, and when this ownership, Sterling Properties, purchased it in 2007 and then was sold in 2017, during that decade, we made numerous changes to it. But when they bought it, they were looking at repositioning this building. This building had fell to a C, or at least a B minus, but more likely a C status with them. It was the tallest building at one time in Florida in 1973 when it opened, and east and south of Atlanta. So it had a status, and it was a single-tenant building by Florida National Bank. Over time, it fell into some disrepair, and it had dropped in its status. So when we helped purchase this for Sterling Properties in 2007, the goal was to reposition this building and then to put it back into play with the downtown corridor of Tampa at that time, which had many other buildings built at higher levels. One of the key things you see is we took it to a LEED Gold. It was very close to a platinum, but that ownership didn't want to go in that direction. But as you see the 22% water reduction line again, and the 72% waste diversion, because there was a lot of water waste because of the waste diversion, which is several of our speakers have noted. So I highlighted that, so that was a part of our reduction. But at the beginning of this water usage, it was 53% occupied. And this 22% water reduction comes at the end of it, where it's 87% occupied. So we still had a comparable 22% water reduction, even though we increased the occupancy by almost doubling it. So the overall from 53% would have been about a 35 to 36% water reduction. So just to clarify that point. Next slide, please. Okay, so we decided to develop our strategy, and our speakers have talked to these. We went and looked at the cooling tower HVAC system. We went into the public restrooms. We went into the landscaping, and then we went into the tenant spaces. And pretty much as you outlined before of what those, the effect on a building's water consumption is how we went after it. HVAC in this case, they still had 30-plus-year-old equipment running the HVAC, which was very inefficient. It was causing a lot of energy consumption. And the delta T over the coils was less than a 5-degree split. And as most of you who are aware of that, should be 10 or more. So when we looked at that, we were like, wow, okay, here's a great opportunity, but this is a high capital cost. And we started prioritizing what we're looking at. We went to the cooling tower. It was obvious the cooling tower was overflowing. The cooling tower was blowing off water because of the chemical treatment that was put into place. And, you know, so many different factors. So we put a meter on the tower, which had never been placed on the tower. And we eventually applied for a sewer credit for those who know what that is. So we reduce operating expenses to the tenant. We had an abnormal amount of water consumption from the tower, i.e. that the settings for the tower was overflowing. So it was just going down the drain. And then when the valves were closed at night, they had manual valves on it one time. It would stop and the tower would overflow because the water that was being rejected back out to the tower had nowhere else to go. So we identified these factors, and some of them were low-hanging fruit. The chiller system obviously is a long-term project, and we decided through our metering that we could reduce this capacity significantly. And then we went and looked at the building landscaping system outside. It's not an extreme amount of landscaping, but there were planters in the parking lot that were under disrepair. There were the landscaping that was outside similarly was mostly flowers that were being replaced every quarter. There was a lot of water usage. The irrigation system had not been looked at and repaired. We found after we put the meter on it that we were having underground leaks at night after the system was not running. So in the end, we felt there would be a lot of savings, which I'll get to at the end of our overall conversation here. And then we went in after removing the landscaping usage, the cooling tower HVAC usage, that left us with the main water meter that was letting us know what the common areas in the building plus the tenant spaces we're using. As we go into the common area spaces, we had water closets and faucets that were from 30 to 40-year eras. And then also they would replace some of the different systems when they failed with more water conservation, but there was no overall program. So we had everything from more than 3 gallons per flush down to 2, but we had nothing under 2 at the point in time. So we put together a strategy of replacing floor by floor, and the capital cost every year we would go through 3 floors of a 37-story building. And then we actually accelerated after we showed the ownership that we were actually saving them money. And one of the keys, reducing operating expenses in the building. When you reduce the operating expenses in a building, that means that the lease rate or the rate that the tenant is paying to them, more of the money goes into the ownership's pocket. because of the CAM charges for the cost of electric, insurance, water, and all those variables. So as we were reducing costs, the tenants were able to reduce their lease costs, and more of that money went into their pocket. So, and we were repositioning the building using the BOMA EER Energy Exchange Report. We were modeling ourselves against our competition, the other buildings in downtown Tampa. Anyone can buy the BOMA EER Exchange Report. It's a valuable use. So we took the downtown market, we looked at it, and we were trying to not only bring our building into line with those other buildings, but to exceed it in water conservation, energy conservation. So as we looked at what were the best alternatives to this, we felt the low-hanging fruit, the first ones where we changed chemical treatment and the blowdown system, we went to an alternative chemical treatment that didn't require so many cycles, and thus we stopped the water blowdown. From that perspective, we changed the levels in the cooling tower, and then we changed the valving system and put in automated valving systems so that when a chiller would drop off, it would be a slow shutdown instead of just an open or closed valve, which was pushing water out to the tower and it was overflowing at every stop or every start of the equipment. So while those were easy, we had to also plan over this 10-year period. And at that time, we were unaware it'd be 10 years, but we were just programming it into our capital project. We put in exchanging the 3-chiller system out. And so we started putting in capital costs. We took one chiller at a time and changed the chillers out to a much more high efficient chiller, less water usage. So over time, we were almost able to reduce the water consumption by the end of greater than 50% on the HVAC system. So that was an incredible achievement. And in the end, all the chillers were changed out. We changed the piping configurations. We put in expansion heat units, and all of these drove our water conservation projects. And our deltas were back up to 12 degrees across it. So comfort was established to the ownership while we're in these water conservation modes. So the best is to have win-win-win scenarios when you're trying to sell this to your ownerships, but also reducing expenses and also trying to keep your tenants updated on what you're doing and why you're doing it. So when we started on the common area in the bathrooms, and by the way, janitorial closets where cleaning was being handled, they just had valves that could be opened and left by hand. We put on automatic shut-off valves as well as in the restrooms. And we started saving water as low-hanging fruit in that direction. But we went to the tenants who are consuming in their own bathrooms. Some have private bathrooms and their break rooms, and some had rather large kitchens. As the Department of Defense is in that building, the FBI, the ATF, they had large kitchen areas that were being used. So we actually subsidized putting in some of our water restricting type items. Aerators we gave to all of the different tenants. We had a monthly meeting with the tenants and talked about how much reduction had been achieved by the building, and then also how much the tenants had achieved in their savings. So communication and laying out a solid plan, not that it will always go the way you want it, is one of the key areas that we believe will support. And most tenants want to get in line when you talk to them about the reduction. Now, culturally within this group, though, there's others who understand, and I heard that it mentioned that water is cheap in the US. It really is inexpensive for what we get, but conservation is key. And when you present a case study of why would you overuse water and show them the ways that they can save water that are low-hanging fruit and very little cost, most all of our tenants receive very well and we're very active. Next slide, please. So as we went through our categories, we started applying water efficiency to every area. As we were looking at tenant build-outs, what type of materials were we using? What were our contractors using that required washing off at the end of the day? that required materials that use substantial water in the manufacturing, and how could we change those rates? So we had meetings with our general contractor. We had meetings with the suppliers and the manufacturers that we could get in touch with. And we started talking to them about how can we change what this looks like. And so we did that. And over time, we were integrating in more bamboo type materials. We were integrating in, less mudding of sheetrock that requires water or cleanup. And that was very valuable to us. While it's not a significant percentage, everything adds up in the end. We also were looking at inside of tenant spaces, asking them for when they were building out their bathrooms, there's a value, what we call a value engineering section, where a lot of people will take out the low flow type of equipment used in their spaces because it saves them $400, $500, and they're looking for every penny. We were able, in our cases, in sitting down with them during the tenant build-out meetings, and express to them, well, that's $400, but over the life of your space, which is typically 5 to 7 years, we would explain to them that that would save $1,200 as far as water usage. And since water usage is broken up per square foot, or we call pro rata share to all the tenants, then it has an effect on their space, but also every tenant's space. And again, most tenants were receptive when you sat down and just had a friendly, hey, this is what happens, and try to create education in that area. So those were very positive. And in fact, we had a lot of great opportunities to expand those tenants in our space because we had this dialogue going on. Our property managers, assistant property managers, and engineers all were very valuable in that, in trying to keep that. On the landscaping side, even though I'm saving that as last, when we went out, I mentioned to you there was underground leaks, there were drip faucets that were running consistently, there were valves leaking because of no focus on it, planters were leaking everywhere, water was being wasted. We decided to look at doing a cistern system, which is used highly in Europe and in a lot of places. And I remember that was mentioned early on in one of our meetings and our panelists here. But what we do is we were capturing rainwater and using that underground tank to water our landscaping. And we also went away from all of the major annuals and put in colorful Florida approved zero landscaping type items so that we could still sustain color, but we weren't changing them every 3 months and the amount of water consumption. So we were able to see reduction in water on the landscaping, which again was not a huge component, but greater than 50%. So as we looked at that and we were going through all these motions, again, over a 10-year period of time, all of this was done slowly through that decade. And we were able to do most of it through capital expenditures and then operating expenses, which improved the building. So in a building such as this, according to the leases, which we're governed by as managers and engineers, is it says, if you can show the savings over time in your operating expenses, you can repair these types of things or put in new systems to do that. So we utilize that part of the lease to create a much more efficient, much more comfortable building and to change the positioning of this building in the marketplace. So as we went to the final of this building and the ownership said after a decade, all right, we want to take all of these things, we want to go out to market. What is the value proposition of all these changes over it, which is in the end what all of our ownerships are looking for. We had invested a total through the tenant build out, the common area changes, the landscaping, the tower, the chillers that were replaced, and every other type of imaginable thing we worked on. And it had cost us in an investment over those 10 years, $13 million. When we went to the market with the building and when it actually sold, and I'm still in touch with the present owner, he's a self-manager, but we have actually done some presentations together where I talk about where we took the building and where he's taking it to now, even at higher efficiency ratings. We added $17 million to the value of this building. So what does that mean? Of the investment of $13 million, the value increase was 23.5%. Of the building overall investment move, it was about a 5% increase in the building at sale. So this means that not only was it positive for the tenants, we did reposition the building into an A-, and we created a 99 Energy Star rating. And as you've seen, the water efficiency, all because we put a strategy together and worked together on meeting a point in time and taking that building. Again, you cannot fix anything unless you measure it. The sub-metering part of this played the biggest role in it so that we could see what we were achieving, because we would go change out a floor with the restrooms and see, well, our water consumption went down by X if we do this. So by the time we were finished, we had exchanged all of the systems in the building that time, and the owner had expedited us doing that, particularly in the common area restrooms, because we were showing them the savings. So the sub-metering gave us the strategic information we need to present to the owners. The sub-metering helped us as we moved forward with the tenant spaces, as we started putting in water sub-metering units on every major user. There's what we call, light load user and heavy load users, both in electric and in water. So as we were putting in break rooms, we were looking at that. And then we were asking for both on the energy and on the water side that they were using above building standard water consumption through these sub-meters. Therefore, they should pay the excess of that. So that went into our leases, which we started using green leases in that building, which talk about water consumption, energy, and many other factors. So with that, I'll hand it back to you, or if there's any questions.
Okay.
I'm sorry, I didn't say hit slide. So I'm sorry, I hit slide. I went through it without telling you that. So apologize for that.
Oops. Okay. Thank you so much for that presentation, John.
I think we've got a poll that we were going to run. I don't see any questions for John at this time. So we're going to run one last poll here. This is a two-part poll. The first one is about John's presentation. The second one is more about all the speakers that you've heard. The first question talks about Park Tower's success in reducing water use. What was that due to? Was that due to a superintendent's ideas? Was it due to implementing a standard set of BMPs? Was it conducting the water audits to identify the measures? Was it educating the tenants? Or was it both 3 and 4? And then the second question, based on what you've heard here today, is there something that you might be interested in researching more or implementing? And this is just a straight poll for sub-metering, water audits, green building certification programs, smart irrigation, or landscaping. And we'll let that run for just a minute. Okay, I think we're going to end that poll, and I will share the results. Most of the folks voted for 3 and 4, which is the correct answer, and you can see the results of what everybody on the call is most interested in at this time. And I think I would like to go back and maybe re-poll one more time. The first question that we had, which was, what area do you work with? We had about 32 people vote, but there was almost 90 people on the call. So I'd like to relaunch this poll again. And this is just asking you again, are you with property management, or do you work with a utility? Are you local government, or do you work with private consulting? And hopefully we'll get closer to the number of attendees. We just want to get a feel for who all has participated today. We'll let that roll for a minute. Okay, I will just end the polling on that. And that looks like that's changed a little bit. So we did have one question come in for John Scott, which I will read. It says, what suggestions would John have for building managers and board members in approaching building tenants to install water meters? And I
Sure.
think I meant sub meters on that.
Yeah. So changing the culture in a building is one of the most challenging tasks that you have. If it's a new project, it's easy to place it into the lease and make it part of the building rules and regulations. When tenants have existed in a building and going to them, and education is the first step in doing that, calling together a tenant-only meeting to talk about how the building is looking to work together with South Florida Water Management District, with your own local water and sewer groups, to mitigate this and with the growing population of Florida. Most people, when educated about their usage, look to trying to reduce it. But the first step is for you to start including it in your building rules and regulations and your new leases. Second is to have a meeting with your existing tenants. Talk about why sub-metering is important, because if you cannot measure it, you cannot change it. And then start showing them what their water consumption is in different times. So we had the state attorney general's office of 100,000+ square feet in Park Tower. And one of the items is, when I first sat down, it was not of concern to them, even though the GSA does require certain green parts of their leasing. But when I was able, I said, well, let's install the meter, and then let's have a meeting after I have a few months of data, and then let's talk about what next steps could be. Our team sat down with them. We started going through their usage. We explained how many gallons that was per person within their space. That was eye-opening to them. Then we had a discussion about, well, what if we give you the aerators for that and see it change? So it changed. So when they saw it being reduced, they're like, well, what else can you do? And we said, well, here's some other items within your space and your break rooms and everything else. And they became more adamant about water consumption and moving their own employees to follow programs than even we were at the time. So I think education is, I think, just the sit down discussion, but showing them what the results are and why it's important. And many of the things that the team showed early on, which is the usage and the increased population. You have so much data to sit in front of someone and say, hey, population's growing, our water supply is not growing. This is, valuable to us, and it's supporting our overall Florida initiatives and our local initiatives. So I'm going to put education and then measurement and benchmarking and showing results are the key.
Thanks, John. Thanks for that answer. Robert, we don't have any more questions at this time, so we'd like to turn it back over to you, I believe, for some kind of a wrap up.
Yeah, I wanted to reflect back on the poll that we just saw. The majority of, not the majority, but the largest share of folks who participated in that last poll, the one before this one, Jim, about which area would you be most interested in? Can you bring that one up? Yes, the facility water audits grabbed about 40% of folks. And I want to bring your attention to a water audit guidebook that was created by the South Florida Water Management District, specifically for commercial and institutional buildings. And I will see that I can send you a link to that book. It's free because it has been produced by the Water Management District. But I will see if I can have a link to that sent to you all. The book has several accompanying calculators that were created to help you calculate how much water you may be able to save using different intervention measures, and also give you calculate payback periods for those things. So that's something I would like to bring up to all of your attention. With that, I want to just thank you all of our speakers and our BOMA and USGBC partners for this event. And all of you who are viewing this, I would like to thank you all for your interest in helping to sustain our water resources and at the same time create a more efficient building system for your owners, or if you're the manager, or for yourself if you are the owner. So thank you very much for all of your attention and participation in today's event. We hope to bring another event like this soon. You'll be notified if the subject matter is of interest to you. We please invite you to participate. Jim, did you want to close with any remarks?
No, just to thank everyone for their participation and thank our speakers, and look forward to something next year. We hope to do this annually or continue to do it annually. Thank you.
Thank you very much. With that, I think we'll be closing the event. Thank you so much.